Okay, so let's do one that's just a bit harder. So it says use the definition to find g prime of 2 of g of x. So first we have to interpret what they're talking about. So g prime of 2 means something very specific. In math class, g prime of 2 says g prime of 2 would be the limit as x approaches 2 of the limit as h approaches 0 of f of x plus h minus f of x all over h. So basically they're asking you a two-step question in one single little bitty thing. So we're going to have to take this in stages. I mean, they gave us g of x, fine, but we're going to have to find g of x plus h minus g of x all over h first. So let's see here. G of x plus h and there's really not much we can do with that, is there? I mean, simplify, distribute the 3, and that's pretty much it, isn't it? So subtract the g of x and we're going to have to remember how to subtract those. Well, how do you add or subtract fractions? You got to have a common denominator. There's not much we can do with that. So we get to do this the extremely annoying way, but it still works. So, let's see here. Sometimes called cross multiply. We multiplied this denominator over there and that denominator over there, and then the subtraction stayed in the middle. So now we simplify as much as we can. Alright, I'm just going to ignore my denominator there for a bit. Just kind of have a side note. So let's see here. We have 12x plus 4 minus 12x minus 12h minus 4. So the 4's will cancel and the 12x's will cancel, leaving us with negative 12h over that same lovely denominator. I think that's about as simple as that's going to get, isn't it? For that lovely part. So there's that. Now for the over h part, this is not going to be pretty. So, I mean, technically we do that, but how do you how do you divide complex fractions? You multiply by the reciprocal of the second one. So I can do this, and it means the same thing. That h and that h will cancel, leaving me with negative 12 up top, and that same lovely, annoying denominator. Okay. I think we can apply the limit now. So, the limit as h approaches 0 of that crap. Well, my h is going to cancel or eliminate entirely. So that will leave me with negative 12 up top and 3x plus 1, 3x plus 1 on my denominator. That's about as good as that's going to get. I think, well, oh, nope. They ask us to find the derivative of g prime of 2. This is just g prime of x. So for g prime of 2, we would want the limit as x approaches 2 of g prime of x. So that's a substitution question. So negative 12 over 3 times 2 plus 1 squared. We can simplify that just a bit. So that's negative 12 over 7 squared is negative 12 over 49. Whew! That took a minute. But the definition didn't change. The definition of the derivative didn't change. The definition of the limit didn't change. It just took a little bit longer because the function was a little bit more annoying. But the steps don't change. So the definition doesn't change. Okay. So now we determine the equation of the tangent line to the graph at 2g of 2. So the equation of the tangent line, that is y minus y1, mx minus x1. That's the formula. Okay. So we have almost all the information we need. We just found that the slope at the tangent line at x equals 2 would be negative 12 over 49. So x minus 2. And then all we need now is to figure out what the y is. So g of 2. So we put that into calculator. Simple substitution. Notice that that's g of 2, not g prime of 2. So you're plugging that into the original, not the derivative. So that would be 4 over 7. And solve for y. So, negative 12 over 49x plus 24 over 49. Add 4/7 to both sides. And we get just like that. Use your calculator as much as you can to make it easier on yourself, but also use what you know. The definitions don't change. So we can do even the most annoying derivative using our definition of a derivative, because the definition doesn't change ever. Okay, so let's do another one. So find the derivative of f at x equals negative 1 of this lovely function. So, the first thing I'm going to do is find the formula for a derivative. So, f prime of x, so that's the limit as h approaches 0 of f of x plus h minus f of x all over h. So f of x plus h, so that would be 3x plus h squared minus 2x plus h minus 3x squared minus 2x, and simplify. So all I did there is that part. That's all I wrote down. Okay? So if you take it in stages, then the chances of errors goes down. So let's see here. 3x squared plus 2xh plus h squared minus 2x plus h minus 3x squared minus 2x. And the fastest way to a headache is to do the math in your head. So one step at a time. So 3x squared plus 6xh plus 3h squared minus 2x minus 2h minus 3x squared plus 2x. Negative times a negative. And let's cancel some stuff. So we can cancel the 3x squareds and the 2x's. So that leaves us with 6xh plus 3h squared minus 2h. Now let's put this all over h. But another way of thinking, because we're dividing by a monomial, we can actually individually split it apart, and mathematically it's the same thing. So that says anything over itself goes to 1, and that goes to 1, cancels out one of those, but still leaves one of those. So the derivative f prime of x would be the limit as h approaches 0 of 6x plus 3h minus 2, which is h approaches 0, so that'll go away, and our derivative would just be 6x minus 2. Now that's not what they ask us for, but it is the first step to get there. So what they actually ask us for is f prime of negative 1. So the derivative, negative 1, would be the limit as x approaches negative 1 of f prime of x. So this would be the limit as x approaches negative 1 of 6x minus 2. So that would be, it's a polynomial, thus it is continuous, that is, it is differentiable everywhere. So simple substitution, 6 to negative 1 minus 2. So f prime of negative 1 would give us negative 8. Just like that. Let's do one more. So this last one kind of works a little bit backwards before they ask us to go forwards again. So the limit below represents the slope of the curve. Well, yes, it's a derivative, thus it's the slope. At this point, f of a, we want to determine the function f and the number a, and then calculate the limit. Now we know the definition of a derivative, f of x plus h minus f of x all over h. So the f of x here is actually not that bad to figure out, because we have this 3 plus h part here. So because we know that the derivative is the limit as f of f plus h, then x must be 3. So a is 3. And that is the direct from the definition of a derivative. So the x plus 3, x plus h, 3 plus h, x must be 3. And f of x, the 162. So we actually already know this point here. It's 3, 162. They've already figured it out for us. Woohoo! Makes our life a little easier. And then the f of x, well, taking a look at just this, what's it look like? Looks like they substituted in x plus h into the x, so that would be 6x cubed is what's left. So there's your f of x. So they actually did most of the hard part for you in that. Now we get to calculate the limit. Okay, admittedly that's a little bit more annoying because we have that lovely 3 there. So the cube. How to deal with the cube? Well, 3 plus h cubed is the same thing as 3 plus h times 3 plus h times 3 plus h. So, FOIL would get you the first ones. So that's h squared plus 6h plus 9 times h plus 3. And multiply again. So we have h cubed plus 6h squared plus 9h plus 3h squared plus 18h plus 27. Combine like terms. H cubed plus 9h squared plus 27h plus 27. And all of that was just the cube part. Now we can apply the 6 and the minus 162. So that gives us 6h cubed plus 54h squared plus 162h plus 162 minus 162. Those will cancel, leaving us with 6h cubed plus 54h squared plus 162h over h. So that would be 6h squared plus 54h plus 162. And there we go. So the blue, there is that part. And then that part we finally finished there. So now we can apply the limit finally at the end. So the limit as h approaches 0 of that gives us, well, as h approaches 0, it's a polynomial, thus continuous, thus in pieces. Anything with an h still will go away. So the limit as h approaches 0 of that function is just 162. And this would be f prime of 3. So it's a multi-step process. In future sections, we're going to learn more rules that will make this much faster. But for the moment, we have to go by the definition.